Welcome back, dear students. In this video, we shall be talking about Spearman's rank correlation coefficient. First of all, let's understand what do we mean by rank correlation coefficient, then declare a formula for it and apply them in problems. So let's first of all understand what we mean by rank correlation coefficient. Let's consider a group of n individuals and let capital X and Y be two characteristics that these individuals possess. Say the marks in two respective subjects, say mathematics and statistics. And we arrange those numbers either in the increasing or the decreasing order and we rank them. Ranking is normally done using the numbers 1, 2, 3, 4, etc. Assuming that the highest rank is number 1, then the next highest is number 2, and so on. That's the way the ranking is done. And the measure of the degree of relationship between these ranks is now termed as rank correlation coefficient. So we are going to check the correlation between the ranks or the of the two characteristics that these n individuals possess. So Spearman is the person who has derived this formula, and it is given by rho equal to 1 minus 6 times sigma d square by n into n square minus 1. Now, rho is the notation for our correlation coefficient, even ordinary one. We use the same notation even for rank correlation coefficient. Now, D is the difference between the ranks of the corresponding pairs of x and y. If capital X and Y denote the marks, I have denoted small x and y to represent the ranks of x and y respectively. And then once we declare the ranks, the difference between the ranks is calculated. That's taken to be D. A note here that should be is once we declare the ranks always when I take the total of the sigma of D of the difference between the ranks, it will always be equal to 0. That's the check that we need to do before we proceed further. And then we take up D square and calculate the total. So sigma d square is a formula. So once d is calculated, take the square of d, take the total of the d square, that gives you sigma d square. N is the total number of observations. It could vary from problem to problem. And that is the value of n. That's supposed to be substituted in the denominator. And by simplifying using the formula, we get the value of rho. This is a case where the marks are not repeated, so the ranks are not repeated. So the ranks are different for each n individuals. But suppose you have a tie. Suppose you have two or more students getting the same mark. Then what we do is we assign a mean rank for each of them. Now, suppose there are three students getting the same mark, then we calculate what is called the mean rank. I'll explain it to you in the problem. And the value and all the three students get the same rank. So in when we have repeating marks or repeating ranks, then in that case we introduce what is called a correlation factor in the above formula. So what we add to it is m into m square minus 1 by 12. This is a factor that is added to sigma d square. So kindly remember 6 is outside. So 6 is multiplied with this sum. So within the bracket you have sigma d square and you are adding the correction factor, and note that if there are two different numbers. Now suppose I say the mark 70 is repeating 3 times for x, and suppose I say another mark 65 is repeating 2 times, say for y. That means this correction factor that I am using here should occur for each repeating number. So it should occur for this 70, it should occur for 65. So in this case, m is the number of times that particular mark or rank is repeated. So how many times is it repeated? 3 times. So the correction factor will be 3 into 3 square minus 1 divided by 12. And you have another one rank which is repeated, but it's repeated 2 times. Whether it occurs in x or y, it has to be added. So it will become now plus 2 times 2 square minus 1 divided by 12. Suppose you have one more rank, you have 70 or 68, which is repeating 2 times again in x. that also will contribute to one more term, 2 into 2 square minus 1 by 12. So what I'm trying to say is, depending on the number of times a particular mark is repeated, mark or rank is repeated, so many correction factors you will have. If there are three numbers that are repeating, then you will have three correction factors, and all those correction factors have to be added and added to sigma d square, and only then that sum is multiplied by 6. This is a common error that students make. So this bracket is very essential to recognize. And also note that the denominator is only corresponding to the second term. So this first term is just 1 minus the remaining factor that you have as shown. Now the first formula is for non-repeating ranks. The second formula, including the correction factor, is for repeating ranks. We shall use the two formulae in our problems next. So let's start with the first problem. The following are the ranks obtained by 10 students in statistics and marks. So kindly note that he has already given you the ranks. So you are not given the marks. So you don't have the task of finding the ranks. So you are already given the ranks. And of 10 students, so the ranks are already allocated. And you see there is no repeating ranks anywhere. So it is formula number 1 that we will apply. So since the ranks are already given, as I told you, I am representing small x and y as ranks. So ranks are given. There is no other work that we need to do. We simply have to take the difference of the ranks. Some are positive, some are negative. Kindly note that this sigma d will always be 0. When you add up these values, you should get 0. That's the check. Before you go in for calculating d square, I suggest you check the values, the sum of d. That should be 0, meaning that you have calculated correctly. Then find out d square, get the total. Sigma d square is 36 here. Now substitute it in the formula. So in place of sigma d square, you're substituting 36. There are 10 observations. So when you simplify, your correlation coefficient for these two subjects is 0.781. So the first problem that we saw was non-repeating ranks or marks. Here you see, obtain the rank correlation coefficient for the following data is the question. And when we look at the data given, he has not specified whether it's given marks or rank, but I don't think that is needed because it is common sense to judge whether these are marks or ranks. Definitely they are not ranks. So they are all marks given to us. So whether it's for maths, physics, or maths statistics, or statistics, some other subject, that also it's immaterial. We are only concerned with the two subjects X and Y. So here our first step is to rank the given data and then only go ahead with the formula. So we have x values. I have just taken a different color for the repeated marks. So we see here that 80 is the top mark in x. So as the ranking process is done, the top mark gets the top rank. So 80 gets the first rank. Now look at the next number. The next number that we have is 75. You see that 75 is repeating twice. So it's here and it's here. So actually the rank cannot be 2 and 3 because it is injustice to the students who get the same mark. So they should get the same rank. So when there are two students getting 75, actually the rank should be 2 and 3, but we cannot give two different ranks. So as I told you about the concept of mean rank. So what do I mean by that is, whatever the ranks that they are eligible for, I take 2 plus 3, take the mean of it, divided by 2. So that gives me 2.5. So I cannot allocate one as 2 and the other as 3. That's wrong. And hence what I do is I take a mean rank. That is the rank what it should have been. This is 1, then this is 2, this is 3. This is one number, this is one number. It should have been 2 and 3. And because it's repeating twice, so I take the average of it. And now I allocate it as 2.5, 2.5. So 1 is over. The second and the third ranks are now taken as 2.5, 2.5. So this is the first rank, this is the second rank, third rank. So we have completed with 3 ranks. So what's the next rank? The next rank will be the fourth one. So kindly understand this particular step. You have taken up the first rank, there was no repetition. The second and the third rank, there is a repetition. So we took the mean rank. and we found 2.5. So the rank given to this student and this student getting 75 marks is now taken to be 2.5. But actually, we treat that three ranks are already given, 1, 2, 3. So three ranks are already given. So the next number will be awarded fourth rank, and that's 68, which is fourth rank. Now coming to the next number is 64. So fourth rank is over. 64, you see it's repeated three times, 1, 2, and 3. So what should have been the ranks? This fourth is over, so this will be fifth, sixth, seventh. But can we give three different ranks for the same number? No, not possible. So what we do here again, as we took the concept of mean rank, let me show it to you here. This number 64 now assumes three students get it. So fifth rank, sixth rank, seventh rank. This is the actual ranks that we have to give. But as I told you, we cannot give three different ranks for the same mark. So what we do, we take a mean rank. So take the mean of all the three ranks. It is 5 plus 6 plus 7 divided by 3. So that makes it 6. So we allocate now rank 6 for all the three students. Right? So fourth rank is over. That's here. Then we'll treat this to be the fifth rank, sixth rank, seventh rank. So we have completed with seven ranks, but the rank awarded for all the three is 6. Now we move to the eighth rank, and that's 55. The ninth rank is 50, and the 10th rank is 40. Kindly note that we have 10 students, so naturally we have to award only 10 ranks, no, not less than that, not more than that. So we should be very careful in taking the mean and then simplifying. I repeat, 75 is repeated twice here, and the ranks should have been 2 and 3. So we have taken the average of 2 and 3, to taken it as 2.5, awarded it as 2.5 for the two candidates. 64 is repeating three times. The rank should have been 5, 6, 7. We have taken the average of 5, 6, 7 and then awarded the rank as 6 for all of them. So we have completed with the fifth rank, sixth rank, seventh rank is over by count, and the next rank that we go in is for the eighth rank. So that's how the ranking process is done. Similarly for Y. For Y, when we say 81 is rank 1, 70 is rank 2. Now coming to 68, 68 is repeated twice and it should have been rank 3, rank 4. So it is 3 plus 4 by 2, so it will become 3.5. But by number, one is 3, one is 4, so 4 ranks are over, we go to the fifth one, and there is no other repeating rank, so it is 60 is 6, then 58 is 7, 50 is 8, 48 is 9, and 45 is 10. So there are no more repeating ranks. So we see that the rank 64 is repeating thrice, 75 is repeating twice, 68 is repeating twice in both X and Y. Then we have calculated the difference of the ranks as we did in the previous problem. Once the ranks are ready, the problem becomes easy. Again, the check here is sigma d value should become 0. When you add all this, it should give you 0, and only then go in for the calculation of d square. So you have sigma d square to be 72. Now, because there are repetition in the marks and therefore repetition in the ranks, correction factor has to be applied in the formula. And you see what have we done? This is the formula that we wrote in the previous slide. We just carried that forward. But now I have three numbers repeating. One is repeating twice, one is repeating thrice, the other is repeating twice. And as I told you, pertaining to every repeating term, you need this factor to be added. So I take up the first one where 64 is 75 is repeating twice. So I've written 2 into 4 minus 1 by 12. Then I see 64 is repeating thrice. So I write 3 into 3 square minus 1 by 12. And again, I see that 68 is repeating twice. Pertaining to that, I have another common correlation factor. I add up all the values, then only multiply by 6 divided by 990. And then I subtract it from 1, so that the correlation coefficient for this problem is something around 0.5454, correct to 4 decimal places. So this is the way when marks are given, the ranks are evaluated, and then the process is continued as before, but including the correction factor in the formula. So I hope this problem is clear now. The third problem and the final one for this video we have is very interesting. There are 10 competitors in a musical test, and they were ranked by three judges, X, Y, and Z. So we have three judges, and their ranking is what is given here based on the performance of the 10 competitors. So you see, the first one has given, the first judge has given rank one for the first competitor, rank three Y has given, and sixth rank is what Z has given. So these are the ranking that has been given by the three judges. We need to use the rank correlation coefficient concept to discuss which pair of judges has the nearest approach to common likings in music. So, how do we judge whether there is a common correlation? Which two people are closer? Is it X and Y, or is it X and Z, or is it Y and Z? So, how do we check that? Normally, what do? We calculate the correlation coefficient for by taking two judges X and Y, then we calculate XZ, and then we calculate YZ. So once we calculate the correlation coefficient, taking them in pairs. Now that we have three, we cannot do all the three at the same time because we don't have a formula which accepts that. So we will take them two at a time. So we'll take X and Y first, judge what is their correlation. Then I take X and Z and check what is their correlation. Then take Y and Z and then check what is their correlation. Once we calculate the correlation values, choose that one which is positive, because positive correlation meaning both have the same way of thinking. Negative correlation, what does it mean? If one thinks positively, the other thinks negatively. So we are not interested in that because we are talking about common likings. When I say common likings, it means both of them are thinking in the same lines. So both have to be positive. So the correlation should be a positive value, and if at all you have more than one positive, it choose the highest correlated value. So the way in which you decide is, suppose all of them are positive, then choose that one which is the highest. If you see one is positive and the other two are negative, choose the one which is positive. So if you have more than one which is positive, then choose the one which is higher in value. So that's how we judge that they have common likings to that particular attribute. Here it is music. So since I am taking them in pairs, I have to find three Ds. One is D1, one is D2, one is D3. So I am taking the correlation, the difference of ranks between X and Y, X and Z, and then Y and Z. So let us draw the table now. You see the table is drawn this way. The first three columns represent the ranks X, Y, Z. So the first judge, second judge, third judge. Then as I told you, we are taking them in pairs. So I'm taking the difference of X and Y, X and Z, Y and Z. So I get three Ds. I call them D1, D2, D3. Kindly note that their sum should always be 0. Before going in for the squaring, kindly ensure they are zeros. Then square the values and get the totals of D1 square, D2 square, D3 square. Using D1 square, you will find out the correlation between X and Y. Using D2 square, you will find the correlation between X and Z. And using D3 square, you will find the correlation between Y and Z. So the table is pretty simple to understand. Let's go to see the formula substitution now. You see, now we have started with substituting row xy, meaning the correlation between judges x and y. I'm using d1 square because d1 represents x minus y. The value is 200 there, so I substitute it. I get a negative correlation, and the result, the numerical value is 0.21. So that's correlation value between the judges x and y. Between x and z, sigma d2 square is 60. It is positive. It is 0.64. Between y and z, by substituting sigma d3 square, which is 214, again it is negative. As I told you a few minutes back, if it is when I want to check whether two judges are closer in the or are think in the same lines, it means their correlation value should be positive, and among positives it should be higher. Now you see this is negative, so we are not interested. And I say negative itself, that means x and y are not correlated, they think differently. And here, when you say negative, again, Y and Z think differently. So, which is the only sign that is positive here? X and Z. And so, we can definitely conclude, because it is maximum and it is positive, it is concluded that the judges X and Z, they think in the same line or have the common likings in music. So that's the conclusion. So this is an application where rank correlation coefficient can be applied, and it's a very interesting problem, in fact, to explore on. So I've given you a few problems for practicing. The first problem is where the ranks are given directly. They are given in terms of coordinates. So that means here you have maths first rank in physics, second rank in maths, third, 10th rank in physics. So that's the way you draw the table. Ranks are given of 16 students. You just have to find out D square, substitute it in the formula to get the rank correlation coefficient. The second problem is similar to our second problem in the example where marks are given. So you need to do the fixation of ranks and then you evaluate the rank correlation coefficient. The third one is similar to the common likings in music. Here it is cookery, which we have given. But again, three judges. Check which of the two pairs of judges have a common taste in cookery, so that you could check out using similar to question example number 3. So these three examples are exactly similar to the three examples done in the video. So this is a very simple topic but highly applicable in order to make such a standard conclusions like these. So a very important tool. So with this, we come to end of correlation. So what all we have studied is how to obtain correlation using our three standard methods like direct method, assumed mean method, and the actual mean method. Then we also took up problems where corrections had to be made and then found correlation coefficient to be found. Then we used it for bivariate frequency distribution. And now, of course, we did the rank correlation coefficient. So these are the topics that we are touching upon in our first part of this unit. Next video shall be on regression. So until then, goodbye, and hope you all practice these problems and perfect yourself in the concept of correlation. Thank you. Take care.